All right, let's take a look here at number 1 on this worksheet. So we have 3 runners, Ben, Carl, and David. And we have information that says the distance they ran and the time that it took to run that distance. So looking at these numbers, notice that all 3 runners ran a different distance, and therefore that's why it took each one of them progressively longer to run the time, because Ben only ran 60 meters and took 6 seconds. Carl ran 100 meters and took about 10 seconds. And David ran 150 meters and ran 15 seconds. So the question asks us, who is the fastest runner? Now, obviously, Ben, if we just look at the information, took 6 seconds. But it's not fair, right? Because each runner had a different distance. So it's not fair to just to look at the time and say, oh, Ben's the fastest because he took the shortest amount of time. So the best way to describe how to know who's the fastest, we have to make them all in the same equal playing field. If there was something that we could look at to compare all the runners, and it's something that we've been talking about in the past couple of days called the unit rate. And so if I find the unit rate, meaning the rate of speed of which they were running, because they were all running an average speed during their 60 meters or 100 meters or 150 meters. If I find their average speed, then I can compare their average speeds and see who's faster. So does that make sense? So rather than looking at just the time or the distance they ran, if we put them together, meaning we put distance over time, because time always goes in our denominator, because time is, again, when we talk about time, we want to know the length of something over time, typically. So we're going to put our information in here. We're going to find the unit rate for each runner. So we'll start with Ben. So as we talked about, so I have distance and time, and typically when we're measuring unit rate, time will always be in the denominator. So that will mean 60 meters divided by 6.34 seconds. So again, we already know that they ran different times and different lengths, so we want to set it all equal. We want it to have a denominator of 1, meaning we want to have a unit rate. So how do I get from 6.34 to 1? Well, that means I have to divide by 6.34. And 60 divided by 6.34 will give me 9.46 when I round. So Ben ran 9.46 meters per second. Now, in America, I know we're used to miles per hour. Sometimes we even use feet per second. But meters per second is essentially the same thing as miles per hour. It tells us how fast something is going. So how quickly is it moving? So we just did Ben, now let's do Carl. Remember, we put meters on top, seconds on the bottom. And to compare them, we need to make our denominator 1 second, meaning we have to divide 100 by 10.23, which will give us 9.78 meters. So Carl ran at a rate of 9.78 meters per second. All right, then finally we have David. So David ran 150 meters over 14.98 seconds, but we want to find out how fast he ran in 1 second. So we divide 150 by 14.98, and we're going to get 10.01 meters per second. So, looking at all these numbers, again, we're tempted because usually we want to find the smallest number, right, which is 9.46. But we're talking about the speed of something. Do we want to know how small the speed was? No, we're trying to find out how fast someone was going. So, usually when we talk about speed, we want to know how the fastest time is or what the bigger time is. So, 9.46 is not faster than 10.01. So, David was the fastest runner because his speed was greater than Ben and Carl over the same amount of distance. So again, we had all these different numbers, but we used the unit rate to compare all 3. And by looking at the numbers, we can clearly see that David was running the fastest for the distance he ran.